We're going to get started. Thank you very much for joining the West New York School District's presentation of concept to prototype. And we're going to be highlighting Memorial High School's STEAM Academy. My name is Scott Warren. I'm the principal of Memorial High School. I'd just like to recognize some people. Dr. Rappalat, who is the Commissioner of Education, is here. Thank you very much for coming. Ms. Clara Herrera, the Superintendent of Schools, is here with us today. Just to save time, majority of central office is here. We have and then the rest of the presenters you're going to see today is Mr. Barquin, who is the science supervisor, and we have a bunch of teachers from our STEAM Academy that are with us today. We have Jesus Fernandez, who does the robotics, Tracy Goyachaya, who does the math end of it, Mr. Grossinger, Ronnie G, who does the shop, and Dave Kornitzer, who's our science teacher. Before we get started, I just wanted to give you a little, I'm sorry, yes please. So, you hear West New York, most people say, well, why are you here? It's New Jersey. Well, it's west of New York is the town. We're about a mile north of the Lincoln Tunnel. Okay? It's densely populated. It's from the 2007 census, we're the third most populated city in the country. It's about a square mile, and it has over 49,000 people in it. Okay? The district has over 8,500 students. 80% of them are economically disadvantaged. 91% are Hispanic. Besides the 91% that are Hispanic, over 78% speak Spanish as the first language at home. Okay? The district's made up of an early childhood center, 6 elementary schools, 1 middle school, all feeds into the high school. Memorial High School is made up of 3 buildings with over 2,000 students populating the 3 buildings. Luckily, they're all next door to each other. So, STEAM became a district initiative. It started as a pre-K to 12 initiative, and that's extremely important to the district. Okay? It all started off with the superintendent's vision, which became her goals, and of course, central office supported that. So since it became the district goals and the superintendent's goals, it became the administrators and supervisors' goals. We aligned our goals with the district goals, which was important. And in order to make the STEAM initiative important, we needed the teachers. They're the ones with the students, those are the most important. And to get the students involved, we had to get the students' input. Luckily, we're a high school, and our students and our teachers will definitely let you know how they feel. So getting their input was extremely important, because we wanted the student-led, project-based learning. You know, the buzzwords we all hear, but it became that because we got the input of the people that are actually in the classroom doing the work. So when we sat down as a team, we had to look at what staff we had. We couldn't hire any more staffing, so we had to look at the staff we had, and we had to bring in teachers and staff that bought in initially, and that could work as a team, okay, as a group, because that's what we were looking for. From there, we looked at our courses that we had and the scheduling. So we saw some of the courses that we wanted to offer, and then we saw other courses that we wanted to offer but we didn't have. So we had to rewrite some of the curriculum and rename the courses. From there, 2,000 students, 3 buildings, we had to look at the whole master schedule. So again, you have to see it's the whole team effort, which makes this extremely important if you're going to implement something like this. Then the all-important word of budgeting. Initially, there was a lot of money, some money that had to go into it. We had to pay for after-school stipends, some initial equipment, some software, and other miscellaneous needs that we needed. But with the district giving the school some money and then the money allocated, the school allocating some of its funds to the STEAM Academy, we were able to come up with the funds that we needed. Again, we're an avid district. Okay. Extremely important to the beginning of the STEAM Academy and continuing the STEAM Academy to grow are our partnerships that we have with different groups. We have 2 colleges that are extremely important to us, Stevens Institute of Technology and NJIT. Luckily, Stevens is very close to us. It's about 2 miles. Okay? And we also have a partnership with Liberty Science Center. Now, these 3 partnerships not only give us a lot of professional development, they give us resources inside the classroom and outside the classroom so we can have some hands-on resources that we need at our hands. Yeah, so the STEAM Academy originally started in 2015. It was an after-school club that we had a relationship with NJIT, and it was an engineering club. 2016-17, we then made it an after-school academy. We hired some teachers to stay after school with the students. It doubled from 10 to 20 students. 2017 and 18 is where we rearranged our schedule, and it went to 40 students. Currently this year we're at 100 students in the STEAM Academy. Again, it's during the school day and after school. This allows other students that might be interested in other programs that we have to participate. It jumped from 40 to 100 very easily because kids started coming in excited about STEAM. Okay, we had kids coming from the elementary schools and the middle schools. They were all doing STEAM at the same time. So when they came in, they already knew the hands-on activities that were offered, and of course they're excited about it. Not only does the 100 students show how excited we were, we want to hear a success story. Last year, out of our top 10, 5 of them were in our STEAM Academy, all going to an engineering school, and are females. So that was important. So now you have economically disadvantaged Hispanic females, 5 in the top 10 going to engineering schools, which was extremely important to us. Now, as we said, the students were extremely important. There's going to be 2 student testimonials here. The first one is the valedictorian from last year, and the second one graduated number 3, and you'll hear she's going to Brown University.
Hello, my name is Elizabeth. I go to Johns Hopkins University. I'm majoring currently in computer engineering. Because of the STEAM Academy during my high school years, I was able to get a sneak peek into the robotics world before I entered college, which also allowed me to learn Robot C, which helped me jumpstart my coding college career.
Hi, my name is Riley. I am from Memorials class of 2018. I currently attend Brown University. Now, STEAM Academy has helped prepare me for college by exposing me to the engineering design process. I use it heavily in my engineering course, and also has helped me work with a team when it comes to building our projects with that course and working in labs.
So at this time, I'm going to introduce Mr. Frank Barkwood, who is the science supervisor. Frank?
Good afternoon, everybody. My name is Frank Barkley. I'm going to give you some background information. I'm actually a product of the West New York school system, K-12, taught 17 years, mostly in the high school, and it was a great pleasure to help develop this program with the superintendent, Dr. Herrera, Principal Warrat, and my great teachers over here and the students. I also coach track, and the only reason I'm mentioning that Elizabeth and Riley, the 2 students that you saw up there, actually started freshman year. I coached them girls tracking, and we're proud of what they accomplished. Riley's going to Brown right now, and Elizabeth's going to Johns Hopkins, both computer science, and the other one is engineering. Right now, as Ms. Warren stated, we have a bunch of courses that we have all kind of isolated. So what we did was we want to kind of integrate the system so that the students have meaning to what they're doing. One of the most popular questions I used to get as a teacher is, why do I have to learn this? How am I going to use this? And being able to make those connections and having these classes linked. So a student in Algebra 2 STEAM is also in Intro to Engineering. We also might be in Advanced Robotics. And if it doesn't work out that way all the time, we also have the after-school program, which allows them to work on projects. Because in a 40-minute timeline, in terms of what the class period is, it's impossible to get the projects done in that time frame. So why STEAM? Okay, and that goes back to where I said, why do we have to learn this, right? STEAM allows you to promote and apply the 4 C's, right? Critical thinking, creativity, collaboration, and communication. You know, the current job market now doesn't need memorization, and learning through lectures is not very efficient or practical, right? But the ability to look at a problem, analyze a problem, look at the requirements of the problem, deal with the constraints of the problem, think out of the box, and communicate those solutions, have multiple solutions, is what 21st century is all about, and it gets our students future ready. From concept to prototype, that's our whole theme. Okay, basically this goes from kindergarten all the way down to 12th grade, and we always try to start with a real-world application, making it meaningful. and then we solve the problem. Whatever the problem is, you have to get a solution. And then you use the content to use that to solve that problem. And basically, we have your engineering requirements, your constraints, using that design process. And basically, something that in education we always kind of look at failure as bad. But in terms of engineering and problem solving, failure is not only good, it's expected, and that's the way we learn. So getting that to the mindsets of the students, and sometimes the teacher is a challenge, but it really shows value of what you're learning and how to improve it. Now, one thing teachers always ask is, how do we judge our students? How do we assess them? And the answer is based on how they can explain their project. If they can explain how they succeeded, or how they failed, and how they implement to improve it, that's how we assess them. The other thing is there's constantly revisions. So when you go and you have an Apple, there's Apple 10 right now. So we don't look at a program saying, all right, we're done with this, and we're constantly trying to improve it. And that's, the goal of Student Academy, and that's what we kind of go from, we lead by example. We try to improve our program, students try to improve their projects. One last thing before we go on is that our projects really aren't instructions driven. It's not like an IKEA furniture kit where you get the instructions, you follow the instructions, and you build it, right? It's basically from scratch, from a concept. So, an example here would be a picture right there, that's the actual concept of an aquaponics system done in our environmental class. Now, those students also have Mr. Grosinger in what used to be his machines class. It's now called Intro to Engineering. So they do the drawing, they figure it out, and then they have to reconstruct an existing structure. So this wasn't boards, this was something we had some lights on, and Mr. Grosinger had to figure out with his students how to strengthen it so it could become part of the aquaponics system. To explain that, I had Mr. Grosinger to come up and kind of how it implements that stuff in his intro to engineering class.
All right, so let me say I'm really lucky to be here. This is such a supportive group. I didn't have shop class growing up. This has a shop class where you can actually make things. So speaking directly to this is one of the parts that the students made. These are all made by different students. So the support structure is like this, but it kind of goes a little bit rhombus. So the best way to fix that would be to make a triangle. Okay, so this is basic stuff. But what it is we put the challenge into the hands of the students to actually make the part and then install it in the device. So I'm prepping you for a video you're about to see where the girl talks about going from concept to prototype. She has a cardboard model, then she has she tries out one, she fails, she don't care, she tries again, and then she uses the machines that we have. Some of these machines are left over from World War II. They're very old machines, but we're using it in a modern fashion where we don't mind failure. We're learning about how to go from concept, and it's okay to fail, and into prototype. The other thing about the video you're about to see is that there's two machines that can make all of the other machines on planet Earth, which is the mill and the lathe. That's the mother and father of all the other machines. So when you hear about a company like SpaceX, run by Elon Musk, who runs Tesla, how is it possible that they were able to take contracts away from United Launch Systems or Boeing or Lockheed Martin? How is that possible? And if you read a book about Elon Musk, you'll find out that what he did was he brought everything in-house and he actually made stuff from scratch. He thinks, how is the best way to make this? Not how do I buy it? How do I buy this contractor? How do I buy this part? Believe it or not, NASA was buying rockets from Russia, current day. And he came in and said, you know what, I'm going to disrupt that industry. So I'm about to show you two machines that make that possible. Even though those machines are very old, they are still the cornerstones of the industrial arts process. Okay, let's take a look at the video.
What we're showing here is the gusset, and you guys have seen the gusset before, but we probably didn't hear from the students directly. So let's talk to Jocelyn.
One of the first issues in aquaponics was actually stabilizing the light stand. And in order to do that, we were introduced to the ideas of a gusset. So we had to get a piece of metal or aluminum, then we had to cut it, and we had to draw a prototype, then draw it onto the piece of metal, and then cut it out. And then this by itself was flimsy too. It's not like flimsy like it's gonna break.
There you go. That demonstrates it perfect.
So we used a bead roller to not only make designs and make the gussets look nicer and more aesthetically pleasing.
Hard to lift up. So it's a lot stronger. What's this?
Oh, this was actually riveting. To rivet the gusset onto the actual light stand. All this stuff. Each one has to be bolted in.
Where's yours?
It's right there. It took me about 2 months.
Okay, Jocelyn, thanks a lot.
No problem.
This is like a really big drill press, also known as a milling machine, which is kind of like a 3D printer, but opposite. It's a 3D cutter, and we're taking about 20 thousandths. And there's something called a DRO, which is a digital readout. As he turns this. So this is a point. What if you wanted to make that out of steel? Wow. Look at that.
As you can see, yeah, I love this stuff. Yeah, that goes without saying. But basically, anything you want to make that's round, that would be on the lathe. That's like a pencil sharpener, but you can adjust it for any size you want. And then anything you want to make that's not round, that holds the thing that's round, is made on a mill, which is kind of like, everybody knows the 3D printer, but really, where it came from was the 3D cutter, which is called a milling machine. Now, the thing you saw where the student put the gusset on the stand so that it doesn't go rhombus is she used aluminum and then she used a bead roller, which is a very old machine. They used to use this in World War II to make airplane parts. It's still relevant today for the design process. And one of the things she did, she talked about rivets. She's putting those little, looks like little dots, right? Those are like permanent bolts. And if you go back in history, everybody knows the girls, the Rosie and the Riveters, they made the airplanes. When the guys were off at war, the Rosies were home, and they went into the factory and they made the airplanes and they made the bridges. And that's where you get that Rosie the Riveter showing and she's got the riveting machine. So what I do is connect the dots for the kids from the base, from the industry, from the mother and the father of all the machines to their creativity. And I have the support of all the different aspects of the STEAM program. So that's it for my part. Thanks for listening. And you can
see how exciting Supposed gets, and we're very lucky to have him in our program. Brings excitement, and the kids love having his class. Okay, for the ratio of our presentation, we'll talk about 3 projects that have kind of been going on for the past 3 years, and you're going to see the growth of each project. Now, the great thing about these 3 projects is that there's skills that go on with all 3 of them. There's coding that goes on all 3 of them. There's wiring that goes on all 3 of them. So there's skills kind of cross. Mathematics goes on all 3 of them. So putting them all together gives meaning to the subject area and allows students to really thrive again. Alright, so the first project I'm going to talk about is the redesigning of the Green Technology House. And the academic skills, we have environmental science, human impact, climate change, all real-world applications. And the academic, that's all in the environmental science. You also have some physics with the wiring and Ohm's law. So you have a bunch of things going on. In addition to that, we have Arduino, which allows you to code for a house, make it a smart house. We have Fusion 360, which we actually 3D printed the furniture and the rendering of the house before we designed it. And solar panels to make it green and to lower our carbon footprint. Alright, so the traditional house was just basically just wires, and we really started with the engineering club, had a bunch of kids, had to find something to do with them, so whatever was in the closet, it was wires and light bulbs. We did circuits, we said, hey, we're going to do the circuits and have a dollhouse, put it in the dollhouse, put a diagram.
My dollhouse,
and
she was younger.
My daughter's dollhouse, yeah, she still wants it back, but you negotiate. So then we kind of put it all together and kind of stepped up to the next level. We had LED lights, solar panels, Arduino, and rather than I explain it, I have Haley Flores explain it.
Hello everyone, my name is Haley Flores from Memorial High School, and we are the Green Technology House team. So 2 years ago, we embarked on our journey with the dollhouse. This is our first house. It was very raw. All it included were lights, switches, wires, batteries, very raw. And one of the main things that we had were these circuits. So we use parallel circuits because if you turn one off, using the same battery source, it allows the other two to still run, and then you disconnect it. And then we also have a main power switch that shuts them all off. Pretty cool, right? So now we are improving to our green technology house. New technology is going to be introduced, including solar panels. We're going to have Arduino technology. And this is our 3D model using Fusion 360 of the dollhouse. It's currently in the process. We are figuring out and designing the staircase that's going to lead from the first floor to the second floor. And yeah, so this is our Green Technology House project.
Hey, a couple of fun facts here. Haley is actually the sister of Riley, so the gene pool runs very strong in that family. You can see her presentation skills, and one thing we encourage in our program is public speaking. So we have these kids constantly explaining to the superintendent when she comes in, teachers, staff, other students. We actually have a STEAM fair at the end of Techspo where they explain to the younger kids, and they make it as interactive as possible. So you'll see pictures of actually the high school student working with the third grade, fourth grade student, putting batteries together and making a circuit together. So it's great, kind of get forces to the young generation. That's just a picture of what she did as she explained it, so we'll just move on. That's the 3D rendering of the house using Fusion 360. That's the solar panel, and the square chair here, our math person that kind of makes all the connections, is going to go over how the angles can get the most energy.
Yes, so just like was mentioned with all of our members, because it's not just the teachers, it's everybody. We try to include everybody, and since I'm math, I'm not going to lie to you, I can find math in a lot of things. It'll take me a little while, but I'll do it, because I'm very good. So when they decided to do the Green Technology House, I said, well, I have an Algebra 2 STEAM, I can bring that together. So I have my own solar panel. And in my classroom, in that Algebra 2 STEAM, we've been testing different angles for the sunlight for my particular room. So then the kids can learn that solar panels are not just put it on a house and then leave. You have to check the correct angle for your placement, northeast versus southwest of the United States, for example. What state you live, how cloudy it is. So using our experimentation, we're checking what angle gives us the best energy efficiency. We're using a voltmeter to read that data, and then we're going to use trigonometry to see how we can place this solar panel onto that house to get that perfect sunlight. So that's how we integrate our stuff together. Another example would be, for example, Mary Poppins. So I kind of worked a little bit with Ron, and we did some magical Mary Poppins props, and that is in a trifold out there. And then you'll see me later in the presentation for another example. Thank you.
Finally, purpose for angles, right? Before you have triangles and all this other stuff. Why do we have to do it? This is why. That's why making the connections makes it meaningful. Alright, now this is Angel over here, and he's been with the program since its inception. He is my 3D specialist in terms of, he's a 3D printer, and he's going to explain to you how he's developing the furniture for the Green Technology House.
Welcome to the 3D printing portion of the Green Technology House. As you see here, we have some furniture made. Now, these furniture are scaled down to 0.075 from their real-life counterparts. In order for us to design this furniture, we went on Fusion 360, and we designed it here using the exact measurements that we use when we converted it down.
So again, when you look at this, when you do 3D printing, you can just get something and download something and print it. But what we do is we actually design it using Fusion 360, and it takes a lot of measurements and it requires a lot more skill level for the students to learn and apply. Alright, so now our house is still under construction. We're targeting a May 27th due date because I have a presentation that day. So right now, I'm going to introduce my 3D anatomy teacher, Mr. Corniter, who is my teaching specialist in 3D and Fusion 360.
Hi everyone, my name is David Cornitzer. I've been with Memorial High School for about 4 years now and with the STEAM Academy for 3. Now, as Mr. Barkman just said, I was an anatomy teacher, which everyone knows science. It gets boring sometimes, and it's very hard to relate in learning. So what did we do instead? We decided to bring technology into it, bring real-world application in. So For instance, for my anatomy class, we decided to choose the prosthetic arm. Now, of course, the students are going to learn, anatomical position, anatomical structure, such as, tendons in the, in the arm, the bone, etc. But again, using the technology helps a lot, especially when creating the prosthetic arm. Now, in order to get started with the prosthetic arm, we first have to learn the anatomy, which, of course, everyone knows. They can open the textbook, easy, why not? But what we also do is use Fusion 360 now to build it. Can we just go to the next slide, please? Awesome. So if you look over here, all the way at the top, we have that beautiful hand right there. Everyone can see it. Now, when we first started 3 years ago, this was it was a trial period. So it was a 2-week period when we took an anatomy class and we had them build the hand. As you can tell, there's lots of problems with it, right? The thumb doesn't move, there's no wrist movement, and honestly, it doesn't look too pretty. But what's amazing is that these kids had 2 weeks to do this, and this is not a template that we downloaded. What they did is they took their own measurements of their hand using calipers that we learned in Mr. Brosinger's class, and they'll literally apply it to Fusion, and you'll be able to see it. And you can see everything, by the way, at the end of the presentation. Back there by the trifle, we have some of our stuff printed out so you can see the progress that we made. Now, we want to keep improving, right? That's the key, improvement. So what do we do next? It's all right. So right there, if you look at the picture down, that was 2 years after our first type, so last year. And what did we have? We created an arm that is able to move on its own, robotic, right? And again, we just keep improving non-stop. Again, as we said the whole time, is failure is super important. Without failing, without trying, how do the kids know what they're doing wrong? That's why I personally feel it's very important to get a 3D structure of it too. It's cheap, easy to create, especially after they make it, so they can see where their failures are. So that's what we were doing here, and again, bringing in real-world applications is super important. You can read about working out all you want. I know I do it all the time. Do I do it all the time? No, and that's why I gained a little weight this year. But what you need to do is get your hands dirty. You have to go to the gym and actually build muscle, and that's what we're doing here. So some of the improvements we decided to make from last year to this year, which we're still working on, is we're going to extend to the elbow. So actually that was done originally from the first time to here. But have all digits have range of motion. Last year, it was a little sketchy. It didn't work 100%, but we're improving. And then we need to find another way to connect the motors and wiring. Just because it didn't work properly, but again, it was a tremendous improvement from, what was it, like 2 years ago? From that first picture to the last one. It's unbelievable. Next slide, please. This is what you'll see back there. As you can just see, the first picture right there. Right over here, this beautiful, beautiful masterpiece here to this one. You can't compare. These kids are improving tremendously. Next. Now, this is one of our students. This is this year's work. And as you'll notice, there's a big whiteboard in there. This is where all the communication happens. Each student, or a set of students, will work together to create individual parts. So one person is going to create the fingers, another person is going to create the palm, and so on and so forth. Now, this communication has to work. Why? It has to fit together, right? So if I build an engine, at NASA, they don't have one person building the entire thing. They have multiple people building, and they all have to communicate together to create something. So we'd like to hear from AJ real quick.
In this section, you'll see the progress we are making on the fingers and the measurements. In this section is the work on the palm. This section's the part of the upper arm where the nub would attach to said prosthetic arm. Here's the exoskeleton of the forearm, this part right here. And this is the inside of the arm where all the mechanisms.
Now again, AJ's one of my STEAM Anatomy students, as we were just saying. And he has come an extremely long way. He's come with not even touching Fusion 360 in his life to now creating and designing a part of the arm, which is unbelievable. Next slide, please. Now, as he was just explaining each individual, not individual, but he was just going through it, I just wanted to concentrate on some of my students, and they're going to specifically talk about the finger, or the phalange, right? So, and as you'll see in the video, they're learning anatomy at the same time. So, can you please get started?
Hello, we are all a part of the STEAM Academy, and we are currently working on a prosthetic arm.
So one part of the 3D arm that we're working on is called the phalanges. The phalanges are made up of 3 parts or 3 components that would represent the 3 joints of the finger. These are our measurements, and this is the distal, medial, and proximal part of the finger that would eventually connect to the palm. And Kim is going to explain the movement.
So in each 3 components in the phalange, there will be one hole where the wires will go through, which acts as an attendant, which is also made out of nylon, which also allows for movement.
Now, I know you might look at the picture and think, well, that's not too defined, like the drawing's kind of, not really all that. It's small. However, these are just big pictures of what their main drawing looks like. But say if I needed all of the measurements, there's actually folders for the kids to put all their work in. So if I know Kim is working on that and I need to look at the measurements, I can go to her folder too and look at all the rest of her measurements. So that's where the communication happens, but not only that. Again, as we said before, just all our courses are interlocked. They're all going over each other. The engineering portion, drawing, that all comes from Mr. Grossinger's orthographic drawing. He teaches them how to draw properly. Math, we need to learn measurements, but not only that, we also need to know, well, how strong do these motors have to be to lift, a 20-pound arm? So math, robotics, right? The motors, the connecting, the programming. This all of our classes need to be involved, and all our students need to take all our courses in order to get any of this done. That's what's making this so special and amazing. Now I'd like to end it right there and go back to Mr. Barkman. Thank you.
Alright, so our last presenter, our last project, Vex Robotics, encompasses math, everything put together. Mr. Jesus Fernandez does an excellent job with the students. We've already gone to one competition, is we're able to know.
Yes, hi, my name is Jesus Fernandez. I'm the Vex Robotics teacher in Memorial. And what I wanted to say about Vex Robotics is, well, robotics in general, is that it's a discipline where you see all the components of STEM come together. And like, well, I shouldn't say that, but like most disciplines, it doesn't. But in robotics, you see it all come together. As you can see listed over here, you do have all these academic and technological skills that are definitely covered in the STEAM program, such as coding, physics, mathematical applications, engineering, design process, mechanical engineering. So one of the ways that this is brought together in a great way is through a competition. There is a foundation called the REC Foundation, Robotics Education Competition Foundation, that every year in combination with Vex Robotics, they design a new game. And in this new game, this year the object of the new game, you might be able to tell more or less what's happening on the slide. What you see there is a robot that, first of all, has to be able to climb platforms. And it has to have enough force in the motors. You have to choose the correct motors. You have to have the right torque. You have to have the right friction. You have to have the right driving skills as you drive up the platforms in order to score points. And that's one of the ways to score the most points. Another way to score points, you can see, if you look closely, you can see that the ball being launched at the flag. So by hitting those flags, you're going to score points as well. So whoever scores the most points is obviously going to be the winner. So this organization gets together every year and they design a new game. And they come up with a new set of requirements, which is what makes it very interesting for the kids and for me as well. Because every year you have to come up with a new role. You can't You might be able to reuse some of the things from previous robots, but you have to redesign the robot in order to be able to score the points and win the game. And you need to understand the requirements first of all. One of the examples I use for the kids most of the time is you guys, how many of you have put together a piece of furniture without reading the instructions? My team. Everybody raises their hands, including me. And then what happens? Oh, does it work? You gotta go back and read the instructions. Well, the same thing happens with the robots. We end up doing it every year, believe it or not. Even if you learn it, we end up doing it every year, but we do better every year. Okay. What you see here is a group of prototypes. Actually, there's a lot more prototypes. I can fit them all in the PowerPoint. But these are some of the prototypes that we built when we first, but throughout the process of creating the robot. Okay, these are different launching mechanisms that you see here to launch the balls at the flags and be able to score points. Because that's the only way you can score, you can move the flags is by launching balls at them. This was our original mechanism to launch flags. That's our latest and the one that we settled on, the one with the flywheel. And that one that you see up there is just the mobile base on which we will install or try to install the launching mechanism. What you see here is a slide of parts, and you might be wondering what is that? It looks very unimportant, unassuming, but it's actually very important because it shows the concept that the kids need to get, are going to get all these parts together, separately. They're not going to get a kit to build on. They have to actually read the requirements, think of prototypes to use, come up with conceptual prototypes, put the parts together, and come up with the physical prototypes. But there is a thinking process they have to go through, and that's where we really make the connections and the learning takes place. How do I overcome this? How do I do this? How do I design this? We'll do it on paper first. We'll go from paper to physical prototype. Change the prototype. How many times? I don't know. As many times as we can within the time constraints that we have before we go to the competition. Until we come up with a final product. So that's the idea of showing that slide that you see there. They have to build it from scratch. There are no kits. Okay, here is the testing of you might be able to identify the devices launching the ball from this previous slide. That's the devices hitting the flags. And we're pretty excited about this because it's our first, milestone, so to speak, because we weren't sure, are we going to be able to hit the flags? Are we going to be able to have something strong enough to hit them, to flip them, because they have to flip. They're not exactly that easy to flip. They won't flip just by a simple hit. You have to hit it with enough strength. How many rubber bands do we put around those? We have too many. If we put too many, we overload the motors. The motors burn, or the motor won't be able to pull them back. So there's so many different things that you have to take into consideration, but we're pretty happy. The kids were happy too. George was very happy too. He's the kid in the helping. He's the one doing the actual testing. And at this point, I'm going to turn it over to Ms. G, because Ms. G is going to talk about the math and the physics behind what goes on here.
So Mr. Fernandez had a bunch of problems to think about. You already heard he said the rubber bands, that the motors work together, tension, and link burning. So he asked me to put some math into it so we can calculate some of the problems away. So I took my Alpha 2 STEAM class again, and I said, well, that's just projectile motion. Projectile motions are parabolas, which means quadratic formula, which means that yes, I can apply it to math. And so, I'm so excited. So if you look back there, I have another catapult, and it's called quadratic catapult. I had every kid make a catapult because it's not enough just to look at one. I wanted them to have hands-on to solve it using problem-based learning. So if you look at that, it has all the math in there, quadratic formula, everything explaining vertex, roots, all of that. And then as the second part of that packet has the physics formula. So the kids can see that the physics formulas actually came from math. I like to think that math came before physics. I'm just saying. So then, but the only thing that the kids have to know is that gravity, well, we use it here as 32 feet per second squared, but then everybody else is 9.8 meters per second squared. But you can look at that packet and you can see that we wanted all the kids involved, not just the team, because of limited resources. So we all work together.
This is our Robotics team. And rather than me introduce them, I'll let them introduce themselves.
Oh, hello there. Welcome to the Vex Robotics team, a branch of the STEAM Academy where we work on robots and go to tournaments to fight the other robots.
Hello, so this is our new robot that we took to competition recently. So the way this robot works is it takes the balls in through an intake and shoots it out with this flywheel. So the way the whole system works is that these new motors here, they increase the speed of all our wheels and gears we have here. But for the flywheel, we actually increase the speed from a 1 to 1 to a 1 to 25 gear ratio.
Yeah, this is Carlos. He's going to talk about the autonomous mode. The autonomous mode is a special period of the competition where the robot has to do everything on its own without intervention from the driver. Let me tell you, I'm going to have him do it.
Hi, I'm Carlos from Vex Robotics team. I'm going to explain what autonomous is. So autonomous is just a series of actions that I have to program the robot to do by itself. So for this autonomous, I program the robot to launch the ball at the flag and hit it, and then make a right and then climb the platform. So I'm going to show you how it does it itself. So I'm just going to flip the switch and the robot will do everything by itself.
Although the ball failed to hit the flag, at that point we were adjusted the autonomous period. So at this point it is ready for our next competition we're going to go to. Another thing I wanted to mention about Carlos is a perfect example of a kid that likes science and didn't know much when he first came into the STEAM Academy for the robotics program, and he's actually become my right-hand man. He knows everything. He actually learned there's a new system that came through that we purchased with the help of Ms. Carrera. We bought a whole bunch of new systems, and they're totally new when it comes to the coding experience. And he actually learned that before. He knows more about it than I do. Just to put it in a nutshell. Okay? And that actually, it makes you feel good. That's when you know you're a teacher. When you're feeling good about the students know more than you do. And after being a teacher, I took that as a prideful thing. But anyway, I am proud of him, very, very proud of him.
He does an excellent job. The kids love the after-school program. I like to mention that we converted a wood shop into our actual workstation area, and you see Vex Robotics, you see the house, you see solar panels. We have 25 to 30 kids there every day. Our biggest problem is getting them out. They're there, they don't want to leave. So we can have more hours for that school program. Great thing. Okay. This is the best part of the presentation, pretty much at the end. I'd like to thank you to the superintendent for bringing us here and allowing us to present. Thank you for being a great audience. Thank you, teachers. Great job. Thank you, Ms. Laura. And one last video. Thanks for watching. Any questions? Yes.
How do you select the students that go into your STEAM program, or is it open to everybody?
Okay. Well, we have two ways of going about it. We have an academic track, and we have a non-academic track. Because we don't want to close it out to anybody. So the academic track, you're following certain levels of courses. Like the other ones, if they show interest, we let them go to the after-school academy. And from there, they grow there. We put them into the actual track. So we have an academic standard, but we have it also open to other students because we don't know when they're going to pass.
Like I see them in my class in intro to engineering, and and so through that we do a lot of experience, but they're a lot smaller. And then there's an advanced, and also they can come after school. So we do have an open, anyone can join, but then it's up to them to join the academy after school, and then take the other classes like robotics or anatomy or math, that matches up.
That everybody gets a chance to do it.
Anyone can do it. And also, I should mention that, I know you didn't ask this, but what happens is, traditionally, the girls didn't go to the auto shop and whatnot, but the girls are the best ones. And also, you should know that the people that run SpaceX, this disruptive new company that NASA always goes to contract for, it's run by a woman. She's the president of the company. Elon Musk is the visionary behind it and the funding and whatnot. but the person who runs it is a woman. So, you know, girls belong in engineering absolutely as just as much as the guys do. You know, so it is open-ended. Yeah.
What grade level are the students?
All right, so we start the academy. At first it was a 11 and 12, and now we're getting from 9, 10, 11, and 12. And actually we'll have a feeder program that's 8th grade, so we're constantly extending it. Also from K to 6, we have EIE units, engineering, where it's like a problem base. There's a story, you have to solve a story. Someone needs to build a bridge, so we have first graders building bridges with index cards, engineering design process. So we're trying to get the 4 C's involved, where they're using the critical thinking, communication, collaboration, and it's going to transcend in business or whatever job that you're looking for.
If you have any detailed questions too, there's a bunch of my cards, you can always email me. We'll get back to you.
Any other questions?
Very impressive.